chemical reaction here that will take place in a test tube. I've got two reactants. One of them is a solution of lead 2 nitrate. I made this earlier by taking some solid lead 2 nitrate and just throwing it in some deionized water and stirring it up and making a solution. The second one that I've got, same kind of thing. This is an aqueous solution of potassium iodide. I'm going to take a little bit of the Ki and a little bit of the lead 2 nitrate, and let's just see what happens. And again, your job is going to be, let's predict the products of the chemical reaction. Okay, so there's a little bit of Ki. That's our first reactant. Second reactant, lead 2 nitrate. And the most noticeable thing here is that brilliant yellow color, really pretty mustard yellow. But what most students also notice is we started off with two solutions that were clear and colorless. If you take a look at them, they don't have any color to them, and obviously you can see right through them, right? They're both transparent. The most noticeable thing about this is whatever we created, it's opaque. You can't see through it. So we call this a precipitate. A precipitate is a solid that forms in a chemical reaction. It's a little bit like the consistency of chalk dust. And what's interesting is that if I let this sit here over time, the precipitate will start to fall to the bottom of the test tube. And if you think about the name, precipitate sounds a lot like precipitation, snow, rain, anything that falls from the sky and lands on the ground. Well, think about the word precipitate. You've got this chalk dust-like solid that formed, and it's going to fall to the bottom of the test tube, and I can actually see a lot of it starting to just build up on the bottom. This chemical reaction is an excellent example of a double replacement. We had two compounds that were dissolved in water, and we create two compounds as our products. One of them happens to be an insoluble compound, which we call a precipitate, and the other compound is actually soluble in water. So let's take a look at the formulas of the reactants and products and see if we can figure out what that precipitate actually was. In this section, we're going to learn how to predict products of double replacement reactions. There are many ways to describe a double replacement reaction, but the most common one is probably two compounds on the reactant side create two compounds on the product side. If we were to use letters, we could show the first compound as AB and the second compound as CD. Note that on the product side, you can tell what's happened here. Essentially, A and C have switched places. A and C often represent positive ions or metal ions. We can also show a double replacement reaction visually. If you look at the circles, the blue circle and the red circle switch places. This is essentially the same as the two positive ions switching places. In the demonstration, you were able to see two clear, colorless liquids being added together. The first solution was called lead 2 nitrate, and the second potassium iodide. Much like the picture that you see, when the two clear, colorless liquids were put together, not only did we see something cloudy forming, it also had a yellow color. We can determine the names of the products by taking the positive ions and switching their places. On the product side, we would say that one of the compounds is called lead 2 iodide and the other potassium nitrate. At this point, you need to remember your formula writing. All four of these compounds are ionic compounds. It's important to make sure you consider their charges and make sure each compound is neutral overall. For instance, On the reactant side, lead 2 nitrate, you need to consider that lead 2 is Pb positive 2 and nitrate NO3 with a -1. Potassium is K plus 1 and iodide I negative 1. So when we go to write the formulas, it would look like this. It's important for you to know that both of these reactants are dissolved in water. You can tell because I've written AQ in parentheses after the formula. AQ stands for aqueous. Now we do the formulas on the product side. Lead 2 iodide, stop and consider the charges. Lead 2 is Pb positive 2, iodide I negative 1. Potassium is K plus 1, and nitrate NO3 with a -1. When we make these ionic compounds neutral, the formulas would look like this. You might notice something interesting. One of the compounds on the product side has a state of matter that shows that it's a solid. Lead 2 iodide is the cloudy yellow substance that appears in the test tube that you see in the picture. It's the same yellow compound that you saw in the demonstration. But how did I know that the lead 2 iodide was that yellow compound which we refer to as a precipitate? How did I know that it wasn't KNO3? That's one of the most important things that we're going to learn about in this video. There are several things to remember about double replacement reactions. As we mentioned earlier, in a double replacement reaction, we start with 2 compounds and we end with 2 compounds. I mentioned earlier that these compounds that were given as reactants are dissolved in water. We call them aqueous solutions. If a chemical reaction occurs, we say that a precipitate has formed. That's the cloudy substance that we saw in the demonstration. A precipitate is not always yellow. It could be white, it could be blue, it could be any color. One thing that precipitates always have in common is that they will look cloudy. These substances do not dissolve in water, which is why we see that appearance. When doing double replacement reactions, you will need a solubility chart. The purpose of the solubility chart is to determine the identity of the precipitate. There are many different types of solubility charts. In fact, some teachers will have you memorize the various solubilities of metal ions. I'll show you in just a moment what a solubility chart looks like. When looking at double replacement reactions, when you look at the product side, if both of the products are soluble in water, that's important to note because it means that no reaction is occurring. There's a lot of vocabulary related to double replacement reactions, and so there's 4 terms that I'd like to talk about briefly. I earlier mentioned a precipitate. A precipitate is a solid that forms in a chemical reaction. We said that that means it's insoluble. It looks cloudy. The word aqueous is a fancy way of saying the substance is dissolved in water. The next 2 words will be important because I'll refer to them when I show you a version of a solubility chart. The word soluble means simply that the substance dissolves. The word insoluble means the substance does not dissolve. Of course, when I show you the chart in just a moment, I'm referring to does the substance dissolve or not dissolve in water? Here's one example of a solubility chart. I wanted to show you how this works and how you might use it to figure out if you have a precipitate in a double replacement reaction. Going across the top, you'll notice I have the negative ions, and going vertically, I have the positive ions. When you're considering the products of your chemical reaction, figure out the name of the product, and check to see where they intersect if you see S or I. For example, if I were looking at aluminum hydroxide, here's aluminum and here's hydroxide, and I see an I. That means the compound aluminum hydroxide is insoluble in water. It does not dissolve, meaning that could be your precipitate. Now, on the other hand, if I had the compound barium bromide, here's barium and here's bromide, where they intersect, you see the letter S. That means barium bromide is soluble. It dissolves in water. That could not possibly be your precipitate. So in summary here, the letter I, insoluble, tells you that that compound does not dissolve in water. That's the precipitate. And if you find S, it will dissolve in water. Now, in some chemical reactions, both of your products are going to show up as S, meaning soluble. What that means is that double replacement reaction actually does not occur. There are no precipitates in it, so nothing actually happens in the chemical reaction. So every time you do a double replacement and you figure out the two possible products, you do need to look at a solubility chart or memorize all of your solubilities and figure out which of those two products is insoluble in water. Let's take a look at 4 chemical reactions. These are all double replacements. I'm going to provide you with the reactants. I'm going to ask you to correctly write the formulas of the two products. Then, after writing the formulas, I need you to consult the solubility chart and find out which of the two products is insoluble. We do that to find the precipitate. In our first example, lead 2 chloride is added to a solution of barium hydroxide. Note that both of these chemicals are dissolved in water. Stop for a moment and think about the products that will form. Go ahead and pause the video if you need to. The two products that would form would be called lead 2 hydroxide and barium chloride. You may notice that one of them is shown in blue. The reason for that is because using the solubility chart, you should be able to figure out that lead 2 hydroxide is insoluble in water. In other words, the lead 2 hydroxide is the precipitate in this double replacement reaction. The barium chloride dissolves in water. It is soluble. For its state of matter, we write AQ for aqueous. In the second example, the two solutions that we are working with are called silver nitrate and aluminum chloride. Pause the video for a moment. Predict the two formulas of the products, consult the solubility chart, and determine which one of the products is the precipitate. In this chemical reaction, the two compounds that form are called silver chloride and aluminum nitrate. If you read the solubility chart correctly, you would find that silver chloride is insoluble in water. It is the precipitate. Notice that there is the S symbol after the formula. In a balanced equation, that stands for the state of matter. In this case, it would be the solid that forms. The aluminum nitrate is given the symbol AQ for aqueous because it dissolves in water. In other words, it's soluble. The third example has us combining two solutions, strontium bromide and ammonium carbonate. Pause the video for a moment and determine the formulas of the products, then try to use the solubility chart and figure out, is there a precipitate? In this chemical reaction, the products are strontium carbonate and ammonium bromide. Knowing your solubility chart and being able to use it means that you understand that strontium carbonate is insoluble in water and therefore is the solid precipitate that forms. Ammonium bromide dissolves in water, therefore we give it the symbol AQ for aqueous. In our final example, we have two solutions, sodium chloride, calcium nitrate. They're added together. Stop and think about what the products would be and write the formulas. Then consult the solubility chart and determine if there's a precipitate. The two products that form are called sodium nitrate and calcium chloride. When you look at the solubility chart, you should find that both of these compounds will dissolve in water. Both of them are soluble. The consequence of that is important because it means there is no reaction happening in this chemical equation. This reminds us that just because you can write a chemical equation, it doesn't always mean that the double replacement reaction will work. It's always important to check the solubility chart to determine if there's a precipitate. At this point, I'd like to talk about a special type of double replacement reaction. It's called a neutralization. In a neutralization reaction, we still have two compounds creating two compounds, but there's a slight difference. In this type of reaction, we do not make a precipitate. The product that forms is actually water. Let's take a closer look. The two reactants that are needed are very specific. One of them is an acid and the other is a base. Perhaps you don't know what it means to be an acid or a base, so I need to give you a few details. An acid is a compound that starts with a hydrogen ion, and a base is a compound whose formula ends with a hydroxide. When these two compounds are placed together, two products will form. One of them is water, and the other one is called salt. The water forms when the hydrogen ion from the acid combines with the hydroxide ion from the base, making HOH, in other words, H2O. When you see the word salt, you probably think about table salt or sodium chloride. But the word salt actually has a more general meaning. It means that we're making an ionic compound. And most of the time, that ionic compound is soluble in the other product, which is water. Here's a few neutralization reactions for you to try. In our first example, hydrochloric acid is added to sodium hydroxide. Notice the familiarity here. Both solutions are aqueous, just like what we looked at with the double replacement reactions a moment ago. But when the positive ions switch, we don't make a precipitate. The sodium ion will go with the chloride ion to make sodium chloride, and the hydrogen ion will go with the hydroxide ion to make a water molecule. The water molecule is shown in blue just to emphasize the fact that we are actually making a product here. In our second neutralization reaction, we have the base, potassium hydroxide, being added to phosphoric acid. Again, these are both aqueous solutions. When we make the products, the potassium ion will combine with the phosphate ion to make potassium phosphate. And the hydrogen ion goes with the hydroxide ion to make a water molecule. In our third and last example, we have sulfuric acid and barium hydroxide being added together. Again, an acid and a base, both which are aqueous solutions. The barium ion will go with the sulfate, and the hydrogen ion goes with the hydroxide, making the two products water and barium sulfate. It is interesting in this case that barium sulfate is actually insoluble in the water. This completes our tutorial on double replacement reactions. Thank you for joining me. I hope you also stop by and watch the last of these videos, which is the combustion lesson. Thanks for joining me, and keep practicing predicting products.